We're going to do another reaction that is somehow related to the previous that we did. When we have halogenations of alkenes, we use the halide, typically chlorine or bromine, and we carry out the reaction in a solvent such as carbon tetrachloride, which is not nucleophilic. So here in this reaction, we're going to be doing the halohydrin formation, and in this case, the solvent can act also acts as a nucleophile. So let's do, say, this is a similar problem that I did in a previous video. So again, that's methyl cyclohexene. So these reactions happen through chloronium or bromonium intermediate. So let's form that. Say that we're doing chlorine, so we're going to form a chlorohydrin in this case. And that in water. Again, the solvent is nucleophilic. So what we're having, you're forming your chloronium. Now, this is your intermediate. And here you will have a methyl group, of course. Now, in the second step, because here you're forming also chloride ions, but they are in much less, say, amount compared to the solvent. So the nucleophilic attack, instead of being by chloride, is going to be by the solvent, by water. Another thing that is important here is where is the attack? Where is the nucleophilic attack? It always happens at the more substituted carbon. More substituted. What carbon is that? So of these two, this carbon has a metal, this has a hydrogen. So this is the more substituted. So the attack is going to be by water, and I'm going to take advantage that this is right here. And it needs to attack from the bottom, since here, this is on wedges. And what this is doing is pushing this out. So that's my leaving group. My nucleophile is water, and that's my leaving group. So let's draw the product of that. So again, attack out the more substituted. Because I had attack here with water. And here you had a metal. This attack from the bottom. So now the metal is on a wedge. Here, this open up. Now you have a chlorine from here. And that's it. So after we need a proton transfer step here. And this is going to be water acting as a base. It's going to be removing this extra hydrogen that we have here. And so the final product is a chlorohydrin in this case. So here you will have OH. That's a metal. And here you will have a chlorine. Another thing that is important, the reaction happens in anti-fashion. So whenever we have those intermediates, like this cyclic structure, and you will have that when you do the hydration with mercuric acetate, and you will have when bromination and chlorination, you form this intermediate. This is chloronium. The nucleophilic attack always happens from the backside of the leaving group, similar to the SN2. That's your leaving group here. So you do the attack on the opposite side. So this is in a wedge. The attack is, the oxygen is coming from the opposite side, so it's going to be in a dash. But chlorine ends up on the opposite side. So at the end, you will have OH and chlorine opposite side. So it is anti. And remember that nucleophilic attack, once you form that, happens at the more substituted. So at the carbon that here had the metal. But because you could have formed the chloronium, instead of having it here, have it on the other side, I have another possible product. So in that case, if I did this on dashes, the OH is going to be on wedge. And of course, you're going to have the metal on a dash. And here, this being on a dash, this is the other product. So now what we have, again, you notice that this is opposite side, so it is anti. Again, this is drawing the chloronium here with dashes, so the attack is opposite side. That's what you end up with. Oxygen on wedge. These two are opposite sides, so it's anti. The attack was at the more substituted. Now, what is the relationship between these two products? This is a chiral center. Here, it has the opposite configuration. This is another chiral center. Here, you have opposite configuration. So these two, the two chiral centers are inverted, so these two are related as enantiomers. Now, they are formed, say, in the same amount, so a mix, 50-50 mix of enantiomers is a racemic mix. We also call that a racemate. And because it's a 50-50, this product is optically inactive.